I'm Selva Prabhakaran. Let's understand the central limit theorem in statistics very clearly. It is a very important concept in statistics. Let's also understand why it matters and how it affects so many other things in statistics also. Alright, so let's imagine you have a random variable x and we have the population distribution of this random variable that looks something like this. This need not necessarily be a Gaussian distribution. It can be Poisson, exponential, whatever the distribution is. It need not be Gaussian. Please understand that. And it has a mean mu and a variance sigma square. So we know these parameters right now. Alright. Now from this, let's sample 30 observations at random. And we do it multiple times. For instance, we have a sample S1. We call it S1. It has n equal to 30 observations. 30 items in the sampling. The mean of that sample is x1 bar, x1 dash. Likewise, we do it again. We have sample S2 whose mean is x2 dash. So on and so forth. We have totally m samples. So S1, S2, so on and so forth till Sm. Likewise, we have the means from x1 dash, x2 dash till xm dash. So these are the different means of the various samples we have drawn. So what the central limit theorem states is, we have the sample means collected from various different samples. These sample means will always follow a Gaussian distribution, no matter what the original distribution of the random variable x belongs to. Originally, the population belongs to a non-normal or non-Gaussian distribution. No matter what the distribution we started off with, if you take samples, multiple different samples, you compute the means of those samples, we have m such sample means here in this case. These sample means will always follow a Gaussian distribution where this sample mean represented as xi bar, alright, xi bar follows a normal distribution with a mean mu. This is same as the population mean that we saw earlier, and a variance of sigma square, which is the population's variance, divided by the total number of observations in the sample. In this case, we took 30 items in each sample, right? So in this case, n will be equal to 30. Let's recap it. Let's back up once and quickly recap. So we started off with a random variable x, whose population distribution looks like this. It is not a Gaussian distribution. It need not be a Gaussian distribution. It can be a Gaussian distribution, but it need not be. This distribution has a population mean of mu and a population variance of sigma square. This is where we start. From this, we draw multiple samples where each sample contains 30 observations in this case. So n equals to 30, and we draw so many samples. And from these samples, we are computing the respective sample means. Now, these sample means, x1 bar, x2 bar, so on and so forth, these sample means will always follow a normal distribution with a mean mu, which is the same as the population mean, and a variance of sigma squared by n. In this case, n equals to 30 because we took 30 observations in each random sample. Now, why does central limit theorem matters in statistics? It allows for so many things, starting off with computing the ability to compute the confidence intervals. So without worrying about the original distribution of the random variable x, we can use the sample means normal distribution. We can use that to compute the confidence intervals. Likewise, we can compare two different sample means using t-tests. Also, this concept can be used by various other statistical tests such as the ANOVA, where you can compare 3 or more samples also. So that's the whole concept and idea behind the central limit theorem. A very popular interview question. If it's clear, move on to the next one where we will solve a problem based on the central limit theorem.